Hi everyone, welcome to today's video where we will be learning how to seamlessly disintegrate a static mesh using Niagara particles in Unreal Engine. In this tutorial, we will cover the full process starting with setting up Niagara FX to properly sample a static mesh. We will then move on to creating a dissolved material that gradually disintegrates the mesh, and then we are going to create a blueprint actor component to sync the dissolution effect with the particles, ensuring that the particles appear only in the areas of the mesh that are disintegrating. Finally, we will add a runtime float curve to manually adjust the disintegration rate. So let's get started. For this demonstration, I will be using this chair mesh from the starter content, and in here I'm going to create a new Niagara system. I will start with an empty emitter so that it's easier for me to set up the modules myself. First, in the emitter update, I'm going to set up the spawn rate, something like 10,000. For very high spawn rates, your particles need to be GPU based with the sim target. So I will set it to GPU compute sim. And for that also I have to set the bounds to fixed. If you face any culling issue, often we find that when we are getting too close to the particles, they start to disappear, and for that you can consider increasing the bound value also over here. So currently the spawn particles don't have any definite position set. So now we need to distribute the particles along the surface of a static mesh. So I will use the module static mesh location. This expects a static mesh variable. So I will create one user defined parameter, read from new user parameter. This makes the variable appear over here. The benefit of using user defined parameter is you can also set the values for that outside the Niagara editor, for example here in the details panel, and also you can set it directly from the blueprint. In the source mode over here, you will see multiple options. When you select source, you can directly pass the source actor reference, and for attach parent, you can just attach this particle to any static mesh component and it is going to automatically detect that as the source mesh. So let's go with the attach parent. When I am choosing attach parent, we can't specify the default mesh over here. Default mesh here indicates the mesh that is going to get sampled by the particles by default. So here to preview our particles, we can just use the preview mesh instead. Let's use the chair for the preview mesh. The particles are very large. I am just going to reduce the particle size, and for that I have to go to initialize particle. And in the sprite size mode, I will choose random uniform. The particles have spawned, but you can see the gaps between the particles. If you want more particles, of course you can increase the spawn rate. This is very high spawn count. It is going to slow down your performance and I don't recommend it. What I would rather do is increase the particle size so they are more likely to fill up the empty gaps that you see over here. This is just forming the shape of the chair. We now implement two things. One is the colorization, because the particle texture should exactly match the texture of the chair itself. And then we are going to add multiple forces in the particle update to create that disintegration effect. Let's start with adding a few forces, and I'm going to choose curl noise force. Fix issue because it also needs the solve forces and velocity module. Now you can see the curl effect, but of course for a realistic disintegration effect this is not going to be enough. Also we want the curl forces to gradually increase, not immediately, and for that in the noise strength parameter we are going to add a float from curve module. This is an ascending curve. Initially the curl is going to be 0, and when the particle reaches towards its life cycle, then the noise is going to be having the maximum effect, and you can also scale the noise over here. So I will set it to, let's say, 100. You can also play with the noise frequency over here. So apart from curl noise, we can add more forces. So let's add wind force to make the particles move along the direction of the wind. Drag module is not set, so I will just fix the issue, and it created the drag force. Let's randomize the wind speed by using a random range vector. Let's reduce the particle size over time so that we can feel that the particles are getting dispersed and fading away after disintegration. So we will use scale sprite size, and I will make this descending curve. So you can see the particles are getting smaller gradually with time. So now I will experiment with the parameter values for the forces till I get something better and closer to what I'm looking for. I'm going to adjust the lifetime to be in sync with the current loop duration so that I can now adjust this in relative to the emitter duration as well. We can further randomize the lifetime by multiplying the current loop duration with some random parameter range. Also, the loop behavior is set to infinite. I will change this to once. So I have the chair mesh already added in the viewport. So let me just attach our Niagara FX. So here the particle is properly spawning. That's perfect. If you want to see the effect again, so just click on reset. Let's add a curve for the wind speed scale as well, because I want the particles to stay for a while before dispersing, and this will also reduce the intensity of the wind itself. Yeah, now I can properly see the particles flowing in all directions, and the curl effect is also dominated right now. Okay, the particle dispersion looks perfect, but we still need to work on the colorization of the particle so that it matches with the color of the chair. Here, when you go to the sprite renderer, you see the default sprite material applied, and we have to use a custom material for this. So let's look into the chair material. Here we can see a couple of textures have been used. We can convert this into parameters because you may want to use the materials for multiple different types of mesh based transitions. Let me duplicate this chair material for the particle. And for this material, we need to use the dynamic parameter node and have to adjust the UV accordingly. So this dynamic parameter node is receiving the values directly from the particle. So I have to also set the values for the X and Y coordinates of the material UV from here. So you have this parameter index which can range from 0 to 3. That means you can have maximum of 4 dynamic parameters with 4 different indices respectively. So that makes it 4 into 4 or 16 float values that you can directly receive from the particles and assign them to your materials. The param 1 is going to be U and param 2 is going to be V. We can either add the UV from this dynamic parameter directly in the textures UV channel. We can also create a customized UV slot, and we are going to make a float 2, and then I will just add this. And also over here you need to use with Niagara sprites since we are using sprite particles, but if you are using ribbons or mesh particles for the rendering, then you have to check the corresponding values. Let's create a material instance and assign it over here. So it doesn't have the color information yet because I have not set the dynamic parameter. So let's do that. So I will add the dynamic material parameters module. Here you're seeing it is automatically taking the U and V parameters from the material I have assigned. Now we need to set the values for the U and V parameters, and those values are going to come from the static mesh location module. So let's look into the module parameters from this parameter tab. here is the sampled UV parameter we are getting, and we need this. Here in the U channel, I will add a make float from vector 2D module. And here in the vector 2D, I'm going to add our sampled UV parameter that I'm getting from the static mesh location module. The channel is going to be X. I will do the same thing for the Y parameter as well, but in the channel, it is going to be Y. Now we have the particles which look exactly like the chair. You can see over here also. The particles are coming rectangular, and that's not something that we want. It is up to you how you're going to shape your particle. It is basically kind of mask you create for the opacity channel in your material. So we are going to keep it simple and just add a circular mask using the radial gradient exponential node. Okay, there is one little issue here. We are setting the customized UV as the dynamic parameter, but for the opacity mask, we have to use the normal texture coordinate. But this is not going to be enough because coordinate index 0 for the UV is already used by the dynamic parameter. So we need to use the coordinate index 1 here instead. And I will add another customized UV for that and set the coordinate index 0 to customize UV1. So that makes the texture coordinate index 1 as the texture coordinate index 0. Yes, so now we have the circular particles. Now I want to add the particle directly as a separate actor because I want to do a side by side comparison on the visual quality between the two. I will just remove some of the properties and keep it bare minimal. First, let's make the loop behavior infinite and let's remove all the forces because I don't want to keep on resetting the emitter while testing. Yeah, here you see they look more or less the same, except some of the properties of the mesh is not visible in the particles. For example, the shadow is not appearing. That is the limitation of the sprite render. If you change the renderer to mesh renderer, you can see the shadows will come, but this many mesh particles are going to slow down the performance. Definitely not recommended, and also this was just for checking if visually they are more or less similar, and this is not my use case. I'm not going to sample static mesh as a separate individual particle. I would rather make this a part of the mesh itself. So in most of the use cases it will not make any sense to create a mesh based particles without any mesh associated with it. Now let's adjust the forces further to increase their intensity and durations. The curl forces is still very high. I will just increase the noise frequency and decrease the force, and let's see how it looks now. Yes, this looks much better. I will also decrease the lifetime and randomize the wind force scale. I also want to adjust the scale sprite size to make the particles disperse and fade quicker. So I will just change the float curve over here. Yeah, this looks really perfect. We can still adjust and randomize the wind forces towards the end of the lifetime so that it looks more natural and spread out. But before fine tuning this further, first let's create our dissolved material for the mesh. I will be creating a material function because dissolve cannot be a separate material. It has to be part of the existing material itself. So I will make a material function where I will be calculating the final output mask. So let's add a world position node, and I also need a local position node. I will add a noise scale parameter. I will multiply this and I will add a tiling also and an offset vector. I can add a mask, get its RG, and I can say that it is our noise UV. So let's see if this works. So I will add our texture. I will use the fire texture because this is perfect for creating something like this, and this is available in the starter content. Let's preview this. The texture is not quite visible over here. So if we reduce the noise styling, then we can see the vertical strip patterns, which doesn't look good, but this is not a cause for concern because we need to check how it looks once we apply on the mesh itself. You can also use a reflection vector, which is typically used for 360-degree panorama viewing. It is up to you whichever method you're using, and you can definitely use the default texture coordinate as well. Now we connect this to the output node. We only need a single channel because this is just going to be the mask. In the chair material, I added the dissolve function. You can already see the mask being applied. Now let's see how it looks in the level. This is the dissolve mask working via the reflection vector UV, and it is looking quite decent, I would say. Let's see how it looks with the world position that we had originally. Yeah, here the tiling is too much, so let's reduce the tiling. Yeah, this is actually looking even better. So we can decrease the initial tiling by dividing the wall position with a high values, for example, something like 100. And now with noise tiling as 1, I am getting decent result. Let's create a LERP to interpolate between the default texture coordinate and the world position UV. Here I am appending another scalar value with the UV coordinate just for the fact that world position is already 3D and LERP will only work between similar types of variables. Now you can change the default UV blend value and it is going to interpolate between the world position UV and the default texture UV. This just gave us the dissolved noise, but we also need to control how much we want to dissolve the given mesh. Let's add a dissolve alpha. So I also want to create a bit of an edge noise for the dissolve with a different color. So I will create some additional variables called dissolved edge width. And this noise will work as the value for the smooth step. This becomes our edge or basically the outline of the dissolve mask. I will make the opacity very similarly. There needs to be a slight offset. Let's make this very low, 0.01. Now we need to add a glow effect for the edge. I will add a power to adjust the contrast of the edge as well. So this becomes edge glow. There needs to be two output channel. For one, I am going to pass the edge glow and then we also need the opacity for the masking. Let's connect them to the respective nodes. I will just add a scale for the power. In our chair material, I will add the dissolve function. Now we need to test how this works. Now let me add a color node which is going to represent our emissive color. and we are going to multiply this by the edge glow. This will ensure that emissive color is only visible around the edges, and the opacity in the opacity mask. Yeah, you can see the dissolve is working perfect with the alpha. The emissive color is still visible when the dissolve alpha is set to 0. So I'm going to simply multiply the edge glow factor with the dissolve alpha. I will further add another parameter to subtract from the edge here called edge fall off, and I will also parameterize the texture. Yeah, it works. When dissolve alpha is set to 0, even the edge glow is not visible. We are done creating a basic noise-based dissolve material. When we work on more advanced mesh disintegration in the upcoming tutorials, we will also create directional dissolve materials, and we might expand this very material function to add those features as well. But this is going to be perfect for our today's demonstration. Now our next task is going to be synchronizing the dissolve properties between the mesh and the particles. The particles are spawning all over the mesh, but by controlling the dissolve alpha very systematically, you can make the particles appear only where the mesh is being dissolved, and for that you have to use the exact same function for your particles, except you just need to invert the dissolve alpha value. That means when the mesh is being dissolved, the particles are appearing, and vice versa. I will add a functional input, invert dissolve, and this is going to be a boolean variable. I will now add a static switch. When the invert dissolve is true, I need to use the 1 minus dissolve alpha, and when it is false, the dissolve alpha value is going to be used only. So wherever dissolve alpha is being used, we will just replace it with this final dissolve. By default, the boolean is set as false, and I will use the preview value as default. Okay, the node is now throwing some error. Let's look into it. Oh, I need the static bool actually, sorry. Okay, so we need to use the same functionality in our particle material also. So let's copy this. Inside the material which we had set for the Niagara particles, here we are going to paste our dissolve functionality. And in the invert dissolve, I am just going to add a static bool and set the value to true. This is going to be multiplied with the opacity mask over here. Let's also connect the emissive color. So when the dissolve alpha is 0, since invert dissolve is true, the particles are not visible, but when it is 1, then only the particles are visible. When I change the dissolve alpha from 1 to 0, you see that the particle slowly disappears, and this is what we are going to make use of. Let me reduce the dissolve alpha closer to 0. Yeah, here you see the particles are appearing only on certain areas of the chair. So now we just need to sync the mesh and the particles dissolution, so that when the mesh is dissolving and the particles will appear on the exact same areas, making the dissolve effect more seamless. Let's first remove the particles because we are going to spawn it in runtime anyway. And I am going to now create an actor component instead. I will name this as transition component. First of all, I will add the component here. In the begin play, I will first get the owner. I'm going to spawn the Niagara system. So I will call this function spawn system attached. It needs a parent component to attach to. So I will add the root component for the owning actor, which is going to be the static mesh actor in our case. And here I'm going to add our disintegration effect. I will connect this in the begin place. So when I am in the play mode, it is going to spawn the particles immediately. Yeah, you can see it works. The particles are spawning correctly. Currently, the material for the particles is already pre-assigned, but typically what I would want is adding the material dynamically to the particle depending on the material that is already assigned to the static mesh. So here the mesh particle material is assigned, but this is going to come from the user parameter. So here I'm going to add a new material interface and I will assign the parameter here. Also, let's add a default material for the parameter. From here, let's call the function set Niagara variable material. The variable name is also material. I want to reuse the same material for the chair itself. It's easier for me. So I'm going to add a variable. In our mesh particle material, I will just add this float parameter called isParticle, and depending on the value of this parameter, I will just toggle between the mesh and the particle material. Now instead of float, you can also use a boolean parameter because Blueprint also supports changing the boolean parameters. We also need to make some adjustments in our dissolve material function. Okay, so we are in the dissolve function now. Here, instead of using this boolean function input, I'm going to use the same float parameter that we used in the main material. This is because it is easier if we just adjust a single parameter in the blueprint that is going to automatically transition between the mesh and the particle. So we are going to assign this material instance to the chair now. And to get the assigned material, we are going to first look for the mesh component from within the owner actor. And for that, I will call this function get component by class. And here I will add a variable called component class. By default, it is going to be mesh component. And when I am in the editor, we can choose between static or skeletal because in the later videos, we are also going to work with the skeletal meshes. And in that case, we can simply choose the component class to be skeletal mesh component. Now we can get the material from the mesh component. There can be multiple indices of the materials also, but currently we are only considering the first index, and when we work with the multi-material disintegration, we will also create the blueprints that can work with multiple instances as well. So now that we have the mesh component, instead of the root component over here, I can directly attach the particles to the mesh component. So we are going to drag this and create dynamic material instance. Set is particle. This is going to be 1. Just also save this particle material. Add another property, set scalar parameter value and dissolve alpha. To set this to 1. Alright, and material is also correctly assigned because if you remember, now by default the particle has the default material and not the chair material. So this is working perfectly, but now we need to just sync it. To be able to change its dissolution property, we also need to set this as dynamic parameter. The mesh component set material, and this is going to be the component material dynamic. Now to update the dissolve alpha in time, I need this tick event. So I need to add this variable called dissolve duration. I will have its initial value set to 5. Now we need to set our dissolve alpha for both the dynamic material instances. Let's add another variable called current duration. This is going to keep track of how much time has passed. I will also add a condition to check if the current duration is more than or equal to the dissolved duration. Then the tick event should not proceed further because the dissolution is already completed. Value is going to be your current duration between 0 and dissolved duration, and output is going to be between 0 and 1. Alright, I think it's done. Okay, the chair is dissolving a bit faster and particle seems to appear a bit later. To address this issue, we can adjust the rate of dissolution further by introducing a runtime float curve. Here you can adjust the curve values to control how fast you want the dissolution to happen. When the timeline is 5, value is 1. When time is 0, value is also 0. This is going to be auto. The dissolution should happen faster towards the end and should be very subtle towards the beginning. So I will just lower these key points. In our event tick, I will use the dissolution curve instead. So I will get the runtime float curve value at a given time, which is going to be the current duration. I will directly connect the result with the scalar parameter values. Yes, this is what I was talking about. Okay, this is infinite loop, so particles are never quite disappearing. So let me just quickly change the loop behavior to once. Let me also adjust the forces to further control and fine tune the movement of the particles. And here I'm going to randomize between 1 and 3. Same with y. I will use this and randomize. And this one also, let's say 0.25 to 1. And I would need this kind of curve. The gradual dissolve effect is still not visible, so I will have to play with the values in the float curve. So I will increase the duration to, let's say, 10, and now I will adjust the curve accordingly so that I can get some sort of gradual effect in the beginning which slowly increases till the entire mesh is getting dissolved. Here we are back to the previous issue where chair is dissolving faster than the particles. To counter that, we are going to add this map range clamped. The input range is between 0 to 1, but here the output range is between minus zero point -5 to 1. It means for the first zero point 0.5 seconds the chair is not going to dissolve. Let me also adjust the other noise properties to make the dissolved noise look much better and convincing. I will also adjust the particles a bit further. I want some of the particles to be affected by gravity and collide with the ground. So for that, I will just duplicate this emitter, and instead of wind force, I will have a gravity force and also collision module. Let me adjust the gravity force. I will add a curve along the z axis. It is going to be slowly increasing with time. Yeah, this looks awesome. You can see some of the particles are falling on the ground and also colliding. I also want some of the particles which are falling on the ground to be affected by wind. So let me add a wind force here. This is going to be along the curve because initially the particles will be affected by the gravity, but once they fall on the ground, they will be swept away by the winds. Yeah, the wind forces are working. Obviously, you can keep on fine tuning more and more to suit your preferences. Okay, so one more thing is left. You might have noticed it before. The shadow is not disappearing the way it should with the chair, and it is only disappearing when you're moving too close to it. There is a quick fix for that. Select the chair mesh and type shadow in the details panel. Here you will see this option, shadow cache invalidation behavior. It is set to auto, switch it to always. The shadow works perfectly now with the dissolution. So this concludes a basic demonstration of disintegrating a static mesh with single material. In the upcoming videos, we will be covering how to dissolve static and skeletal meshes having multiple materials. The project files are available in my Patreon page, so consider supporting me by becoming a member. The link is given in the description. And don't forget to like, share and subscribe to my channel for more such tutorials like this one. I will see you in the next video.